Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope all of you are fine. Here is Aydin Parveen. Welcome all to our regular online chemistry first paper class, English version, arranged by KPB School and College. Today I am going to discuss activation energy, effect of temperature, and effect of catalyst on rate of reaction under chapter 4. The title of chapter 4 is Chemical Changes. At first, I would like to discuss activation energy. You know, in every reaction, new substance is produced. During reaction, old bonds between atoms are broken and new bonds are formed with energy change. So, in a reaction, reactant molecules requires a minimum energy to convert into product molecules. I repeat it again. Reactant molecules requires a minimum energy to convert into product molecules in every reaction. This minimum energy required for reactant molecules during reaction is called activation energy. Only the activated molecule can take part in the reaction and other molecules cannot react till they acquire necessary activation energy. When two activated molecules come in contact with each other, they form transitional activated complex. They form transitional activated complex. At initial stage, the reactant molecule have average potential energy. Look at the figure please. Here EA. EA is the average potential energy and average transitional activated complex has potential energy EX. Then differences between two energies EX minus EA, EX minus EA is the necessary activation energy for every reaction. When activation energy is high, then it is hardly acquired by minimum number of molecules. So rate of reaction become less. That means when the value of Ex minus E, that is activation energy, is high, then it is hardly acquired by minimum number of molecules. So rate of reaction is less. When activation energy is lower, then more molecules acquire this minimum activation energy easily, and then the rate of reaction becomes more. Reaction with lower activation energy occurs at less temperature, but reaction with high activation energy requires high temperature. Now, if you look at figure here, uh, mm, define activation energy of exothermic reaction and activation energy of endothermic reaction. When potential energy of reactant, that is EA is more than that of product, that is EB. EA is more than EB, then residual energy, that is EA minus, that is EA minus EB, comes out. When I repeat it again, when potential energy of reactant, that is here we indicate by EA is more than that of product, that is EB, then residual energy EA minus EB comes out. This type of reaction is called exothermic reaction, and the heat change or enthalpy, that is del H of exothermic reaction, is negative because EA is more than EB. And when potential energy of reactant EA is less, look here, EA is less than EB, that is product, potential energy of product, then required excess energy is absorbed. Then when EA greater than, when EA when EA when EA less than EB, then required excess energy is absorbed from surroundings. This type of reaction is called endothermic reaction. And heat required or enthalpy, that is del H of endothermic reaction, is positive. Then del A is positive. I can repeat it again. For exothermic reaction, EA, that is potential energy of reactant, is greater than EB, potential energy of product. So here some energy comes out, and this type of reaction is called exothermic reaction. And in endothermic reaction, the potential energy of product is less than potential energy of in endothermic reaction, the potential energy of reactant is less than potential energy of product, and here excess energy is absorbed to occur the reaction, and that's why del A's value here is positive, and this type of reaction is called endothermic reaction. Now, effect of temperature on reaction rate. Here you see in the figure, when the temperature is 0, then the time is 100 seconds. When temperature is 0 for the reaction, then time is 100 seconds. And here hydrochloric acid and sodium thiosulfate reacts and produce sodium sulfur. And we look here, when temperature is 0 degree, then time is 100 seconds. That means when temperature is low, then more time is required to occur the reaction. And you see the next step, when temperature increase at 15 degrees centigrade, then the time is less before then, only 40 seconds. And next step, when temperature is increased uh, more, that is 30 degrees centigrade, then time is reduced again, that is 15 degree 15 second. And lastly, when we increase the temperature as 50 degrees centigrade, then time is required only 3 seconds. So from this reaction, we can say with the increase of the temperature, the rate of reaction increase. And what is the reason behind this? The reason is, with the increase of temperature, the average kinetic energy of the reactant molecules are increased. The effect of temperature on the reactant is of two types. Firstly, with the increase in temperature, the energy of reacting molecules can easily overcome the activation energy. Easily overcome the activation energy, and so the rate of reaction is automatically increased. And secondly, as the temperature increase, the rate of collision of the reacting molecules also increase, and that's why the rate of reaction is increased. Now, scientist Arrhenius expressed his opinion on the effect of temperature on the rate of reaction in 1989. According to his opinion, the rate of reaction increases twice or thrice of normal state for 100 degree centigrade increases in temperature. That means if we increase of 100 degree centigrade temperature, the rate of reaction becomes twice or thrice. And K equal to A E inverse EA divided by RT, and this equation is Arrhenius equation. This equation is known as Arrhenius equation, which relates the velocity constant of a reaction and activation energy with temperature. Here EA, the activation energy of the reaction, and R is the molar gas constant, and T is absolute temperature. Now, taking ln taking ln on both sides of this equation, ultimately we get log K equal to log A minus EA divided by 2.30 R into 1 by T. This is another expression for Arrhenius equation. From Arrhenius equation, it is seen that the value of velocity constant, that means K, increases with increase in temperature. And you will have to practice mathematical problem related to this equation. There are several mathematical problems in your textbook, and I hope you all have to practice these problems from your textbook. Now I would like to discuss catalyst and its classification. Before knowing about the effect of catalyst on the reaction rate, at first you have to know what is catalyst and its classification. Uh, is chemical substance which accelerates or retards the rate of a chemical reaction and is never consumed in the course of a reaction, that is, it has no end, and which provides an alternative ways of reducing the activation energy. Actually, catalyst reducing the activation energy between the reactants and the products and remaining unchanged in properties or mass at the end of the reaction. This type of substance is called catalyst, and catalyst may be different types such as positive catalyst, negative catalyst, autocatalyst, induced catalyst, homogeneous catalyst, and heterogeneous catalyst. So I try to give uh, a short idea about different types of catalyst. At first, positive catalyst, a catalyst which enhances the rate of reaction is called positive catalyst. And now negative catalyst, the catalyst which retards the rate of reaction. Retards mean reduce the rate of reaction is called negative catalyst. And autocatalyst, there are some instances in which one of the substances formed during the reaction acts as a catalyst for that reaction. This is known as autocatalyst. That means in this case, this catalyst is produced during reaction. So, in autocatalysis, no catalyst is added from outside. One of the products formed by the reaction is the catalyst, and this is autocatalyst. Now, induced catalyst. When one chemical reaction induces another chemical reaction to occur, then this process is called induced catalysis. The process is called induced catalysis, and the substance that causes it to happen is called induced catalyst. Now, homogeneous catalyst. If the catalyst and reactants in a chemical reaction are in the same physical state or phase, then the catalyst is called homogeneous catalyst. And heterogeneous catalyst, lastly, heterogeneous catalyst, the reaction in which the reactant and the catalyst are in different physical state or phase, and then it is called the heterogeneous catalyst. Now you have already known what is catalyst and what types of catalysts are. Now, lastly, I would like to discuss effect of catalyst on reaction rate. Here you look a figure of, and if you look the figure carefully, you can see there are two ways. One is with catalyst and another is without catalyst. catalyst and activation energy. You have already known what is activation energy and what is catalyst, so I think you can easily understand this figure. Actually, you know, catalyst increases or decreases the rate of reaction because catalysis uh, create an alternative way. The activation energy, where the activation energy decrease, the catalyst create the alternative way where the activation energy decrease. The energy of more reacting molecules can overcome this activation energy easily. Since the activation energy is decreased, so this energy can be overcome by maximum number of molecules and the reaction rate increase. Here you look here, the activation energy without catalyst. This way, this is the path of activation energy without catalyst, and here this is the second way after adding catalyst. And you look here, in this case, in this alternative way, the activation energy is decreased, and when the activation energy decrease, then the rate of reaction automatically increase. So from this figure we can conclude that activation energy with catalyst is less than activation energy without catalyst. So catalyzed reaction go faster. Due to presence of catalyst, the activation energy become reduced, and thus catalyst increase the rate of reaction. No more today. I think this class is helpful for you. Uh, Take care and best of luck. Bye.